Let's now turn the stage over to Marco Fainello, Executive Director and CTO at AddFor and Danisi Engineering, and Claudio Annicchiarico, CEO at Meccanica42. The two will talk about the integration of driving simulators and hardware in the loop, and the associated new possibility of performing co-simulations between facilities that are miles apart without the need to install special infrastructure.
So, good afternoon. It's really a pleasure to be back here and meet so many friends. As most of you know, I always be passionate about testing and simulation technologies, and this is the place to be. Talking about simulation, a successful buzzword is a digital twin. A digital twin is something virtual that it is more or less identical to a tangible thing, but it is physically decoupled from it, as human twins. My question is, when you sit on a driving simulator with a set of hardware in the loop, is it really possible to define the real world and the virtual one as physical decoupled as human twins are? To try to solve this question, let me try to explain why we make use of such tools. In the past, vehicles were seen as a simple set of hardware components, and their integration was mainly important for target setting and performance assessment at vehicle level. There was no particular reason for real-time modeling because the simulation can be done on the single components without caring too much about the time synchronization. But today, the things are quite different because vehicles are better represented by a set of distributed functions, and all of these functions can be enabled by the interaction of different hardware components. It's a completely different paradigm because if the interaction are key for the vehicle functions, then all the information coming from the different components should be made available at the same time in the right time. Okay? And so, this is quite commonly so in these numbers. Today, in a car, there are more than 100 million lines of code, and this number is rising up day by day. So, if interaction are key for the vehicle, now the real-time models become very, very important because they can serve in place of the physical components in any phase of the development process, from proof of concept up to sign-off. And you can substitute the real components with the simulation. In any case, for example, testing different components at different readiness level in the same place. For example, it is possible to test carryover components on a new concept of vehicles months before thinking of the first vehicle prototype. And this is a good example of it. This is the simulation station that we brought here in the booth of Meccanica42, just in front of the reception. And here you have a driver in the loop simulator with the steering system in the loop, the brake system in the loop, and the ADAS camera. In this setup, you can test all the hardware functionalities that are connected to the steering, the brakes, and the camera in the same scenario. And you can have the virtual car and the virtual scenario with the physical components. So here the limit is quite defined between the virtual world and the real world. Here the virtual world are the car and the road, and the physical components are on the rigs. The other side of the moon is the vehicle-in-the-loop technology. This picture is a good example of it. This vehicle has an open architecture in which you can change the kinematics, but also all the components that are installed on it are with an open access. So you can have the 4 brakes individually actuated by 4 electrohydraulic actuators. The traction of the motor is provided by 4 different motors. and the steering is provided by steer-by-wire on both the front and the rear axles. Here, again, the bounding line is pretty clear. Here, the vehicle and the road are real, and the functions are virtually deployed on a virtual actuators. So the answer to my question is yes, the limit is, can be defined between testing and simulation. And this limit is in our hands. In each phase of the development process, we can define which kind of level of virtualization can be useful for our process. And after this, a question can pop up in our mind. Is it necessary to have all the components and the real-time computer, everything in the same place at the same time during the development process? Or is it mandatory to have in the same city, in the same town, all the components? Well, Marco will answer to this question for me. And before leaving the floor to him, I would like to thank you for listening. And I would like to invite you to take a ride of our simulator station, which is just in front of the reception. And thank you again.
Thank you. So as we see today, the combination of virtual testing and real testing is becoming more and more important. Hardware, software, and human in the loop is mainly why we are here, and through the years it has shown the possibility to improve our development process in order to achieve better results with less time and with less money, with less risk. As many people has already said during the day, and Claudio has been summarizing just so far. We have seen that up to today, okay, hardware, software, and human in the loop to be working properly need to be in the same place, more or less. So we also have a sample here of simulators with the human in the loop, with the software in the loop. Software in the loop is also the simulation model and the tire model. I should show, here we are. And you see we have, just in this simple example, but it's just one example, the simulator on one side can be connected to this, which is a steering hardware in the loop system that we use in Danisi and Meccanica42. And the first solution we've been using so far for a very long time is that this rig is a few meters away from the simulator. In this way, the driver in the simulator can drive in a normal, full simulation conditions and can drive the real components, which in this case is steering. It could be the same for powertrain, for batteries, for hardware in the loop, for ADAS, or other things. What we can do, what we found out to be able to do, we're using a technology that I'm going to describe you in a short time, is that using this technology that we call Sibille, we can put together these two rigs, even if they are not a few meters away, but if they are 100 kilometers of distance between each other. Basically, what Sibille is doing is taking some input from, in this case, from the simulator, and use all the input analysis to create a sort of virtual sensor that is just a prediction of the relevant output for the other rig in a forecasting by few milliseconds in order to be able to do two things, basically. When necessary, to fill some small gaps of data transmission, but even more importantly, to completely cancel the delay, the latency of communication between two rigs that are not just one beside the other one. And I show you one example of how this is done. We started a few years ago with AddFor in designing a virtual sensor for traction control. You can see here is a real login of a wheel speed of a car where the wheel is hitting a curb or a pothole. And in red, you see the real signal. In blue, you see exactly the same signal delayed by 50 milliseconds, which is more or less what the ECU would see due to the latency of the communication between the sensor, the processing of the ECU, and the actuation of the traction control. And you can see in green It's a real-time calculation, not a post-processing calculation, of what a Sibylle approach can do in order to be able to anticipate the blue signal to the red, and in this way cancel the latency of, in this case, 50 milliseconds coming from the system. The result of this application, applied to traction control in the car, is that instead of being able to react only 50 milliseconds later with a heavy cut of the engine torque, we are able to have a very smooth control of the engine with much better result. At a certain point, we started to use this same technology to connect different rigs in different towns. And for instance, the example that we brought here, as you can see in the stand of Meccanica42, just behind where you did your registration today, we have a simulator, a static simulator here, where we can drive a model of the car, here in Udine. This simulator is driving a steering model in Torino, in Danisi, 550 kilometers away, which means that the simulator is producing steering wheel angle and load forces that are brought through Sibylle to the test rig in Turin. It drives without latency, because all the latency is cancelled by Sibylle in the middle, and all the communication is checked by Sibylle. The steering rig applies with the robot the same steering angle, applies with the actuator the same loads at the wheels, and gives back to the simulator the position of the rack and the steering torque of the wheels. That's in the same way coming back to here. So the person that is driving the simulator here is actually driving a real steering system that is more than 500 kilometers away in real time. This is just an example. This could be applied to other things. Think about, for instance, running the simulators here, but you have the vehicle model, the tire model, the powertrain model, or the powertrain, the real powertrain on a dyno in another place. In a place where, or the tire manufacturer, or the car manufacturer, without the need to come here, download the model, and use the model where you're using the simulator. You can have human, software, hardware in the loop distributed, where the application of software and hardware in the loop of some components is not anymore a product that you need to make available for the final user, but it's a sort of cloud service that can be available through the cloud. This is all applied just using normal internet connection, a good normal internet connection, without the need of any infrastructure or of any specific investment. We believe that this is opening an interesting scenario of possible application that needs to be invented. It's something that we've been using now at different level for a few years, but now we want to share this kind of technology and understand what kind of application you can think of for different reasons. I cannot make you try here, unfortunately, but I invite you to see even tomorrow morning in the stand of Meccanica42 our guys that can show you what we're doing, and I will be there as well. But I have a video that I can show you where we show some example of the usage of exactly this example, which is just one example, where with a dynamic simulator, we drive a remote steering system hardware in the loop. Thank you.